Good afternoon, everyone. My name is Karel Hendrych. I'm a Juniper systems engineer working in the region, mainly focusing on the security matters. My role today is to give you some quick overview of what can be done for the security in a data center. Then I have something to share regarding some emerging technologies, in particular technology called security intelligence. Then there are some really just a few slides about some management possibilities of the data center. And last but not least, I would like to mention on one slider what was not possible to really squeeze into such a short presentation. Regarding DC security. So first, what is the context of data center network security? Surprisingly, it's the whole data center. So the bottom line of this slide is that there is hardly some one magical box able to cover all the DC security aspects. So if there is someone proposing one box solution, then I doubt it can really fulfill all the network security aspects. There is no such solution, by my opinion. If we look at the core security. That would be apparently some big firewall device, something on a stick attached to some great switching gear, routing gear, you name it. And there are usually big demands for such a device in terms of the performance, scale, manageability, and features. Juniper does offer SRX data center series firewalls for this purpose. So you would find these devices at, for example, mobile operators at the edge of a mobile network and let's say the outer internet. You would find them in some biggest data centers like Apple, some local service providers, content providers, etc. Probably the most important and beneficial attribute of SRX data center platform is their capability of scaling up their performance. So it means that you can purchase upfront some chassis, and if you need for the year one performance X, and you have some, let's say, expectations of traffic growth, then you can upgrade these platforms by inserting some processing modules. And it scales. It scales on the same physical interface. Almost linear. It's not completely linear. I'm a techie guy, so there is nothing completely linear in the IT world. But you are achieving, let's say, almost linear growth on the same Ethernet interfaces just by inserting some processing cards. These platforms also inherited the architecture of the high-end routing platforms, so something which has been there ever since. So the clear separation of the data plane and control plane. So it means whenever the device is booting up under stress or there is something wrong happening to the forwarding part, you can still manage those devices. All right. So what does it offer, basically? It's the firewall and NAT functionality, all the good and enhanced things from the ScreenOS platform. It's capable of facing DDoS attacks from the networking perspective. It's very capable VPN technology. So you can find these boxes, for example, in 4G networks, serving as a LT security gateway. So concentrating massive amounts of IPsec VPNs from the ground stations towards the mobile core. So thousands of VPNs at a scale securing the mobile cores in 4G. Some of the class of services features were inherited, but frankly, you would use NMX with cooperation of NSRX to get the full class of service feature set. It's also the NG firewall, so it's capable of identifying applications based on payloads and treating them accordingly. some applications can be prioritized, application class of service, dropped, subjected to UTM, etc. There's a slide about this one. One of the features is also logical system. You can, let's say, partition these devices into systems with different administrators and, let's say, resource guarantees, so in terms of capacity and CPU cycles. We are probably the only one out there with 100G interface offering for a firewall device. So if you are looking into some future 100G usage, this could be one of the options. Last but not least, robust architecture and HA. We have quite interesting HA architecture on the SRX boxes. So if you put two of them into a cluster, it's behaving like one logical unit. So those of you who are using Juniper virtual chassis technology, it's quite the same, quite similar, consisting of two members having the shared configuration file, shared view on all the system components, and so on. All right. In the previous presentations, you heard how it's possible to interconnect SRX into so-called UAC architecture with external control called infrared control providing user awareness. So this device can be pretty much made user aware by attaching it to radius, Active Directory, PKI, generic LDAP, you name it. So all these functions can be made user aware. So it could be either application tracking, so visibility component, telling you the name of the application, transfer data, application firewall, disallowing access to some particular applications, services, component called application class of service, able to give priority to some services, like if you are running voice and video, you can make them, you can prioritize them so that they will get more bandwidth, different DHCP markings, different forwarding class, if you like, than any best effort traffic like HTTP, FTP, and so on. Last but not least, SRX is a capable IPS device. So it's the IPS engine basically being developed since the A1 secure acquisition back in, I don't know, maybe year 2000 by NetScreen, and since then the engineering is working and improving that technology. The device can also deal with SSL, so either in a role of man-in-the-middle forward proxy or as device decrypting traffic targeted towards servers by putting the private keys onto the device. All right, I picked one representative of the SRX series, high-end series, in particular the smallest high-end box called SRX 1400. I don't want to, let's say, discuss some datasheet figures, but what I want to show you on the next slide is that even this device is very capable. So the smallest device is capable of dealing with the basic configuration, which can be upscaled twice, with something close to 2 gigs of IPS performance, so on a real-world HTTP transactions, but also in parallel, it can survive some extensive flooding attack. So if you take a look onto the counters in the upper right corner, you can see that 2 gig interfaces are being flooded by something like 2 million packets per second, while still the transactions are making it. This is due to the architecture of the hand SRX using dedicated chips for each and every purpose. So the flooding attack is being dealt with the network processor, and the service, the stateful firewall, and IPS is being processed elsewhere. So the distributed hardware architecture is capable of coping with such task. If you take into account the biggest appliance, SRX 5800, so in theory you can scale it 50 times more than this tiny little SRX 1400. So imagine the scale. All right, if we look in our data center in the application layers, there are a couple of ways how we can secure the things. So it was once in the time trend to migrate many dispersed firewalls in front of different resources into the core firewall. So the big firewall got many zones, many rules, many interfaces, and everything was possible to be managed easily from a central device and so on. However, there is a caveat. If you are centralizing too much, then effectively there is a necessary loss of visibility and control in the layers below the core firewall. So the idea of our data center security approach is to have the core device doing the REF segmentation, terminating some VPNs, dealing with DOS, DDoS, and in cooperation with it, to have technology doing the micro-segmentation and services for different tenants. So there are, let's say, 3 different approaches how to secure hypervisors, in particular VMware. The first one is to use the physical security. So each and every VM would be with different VLAN, and the physical security would deal with the connections in between the machines. In theory, it could work. In reality, it's different to configure the things and scale, plus there are some bottlenecks. Another approach could be to have agents, software agents running on the virtual machine. So Windows Firewall, IP tables on Linux, NPF on NetBSD, you name it. But the caveat of that one is how to manage the things. If you have multiple firewalls, different philosophies, you cannot really manage the things. And also, at this point, you are already using the virtualized resources, so virtual CPU, virtual memory, so there's always going to be caveat. Something which can be offered by Juniper is a combination of 2 technologies. The first one is the firewall VM serving some services. So it's a regular virtual machine with a firewall feature set. And the second product is purpose-built security, which sticks into the hypervisor kernel, and it actually does the filtering, the transparent firewall, and many more in front of every virtual machine. At that point in time, the physical hypervisor resources are being used. So there is just little impact, literally little impact on the performance of such a security device. It was already discussed this morning by one of my colleagues, and this slide is, let's say, clarifying and comparing what the products are intended for. So the first one is Firefly Host. This is the internal firewall, and the second one is Firefly Perimeter. This is the VM having the firewall service, firewall capabilities. So inside of Firefly Host, there is no IPS. It cannot do the IPS filtering of traffic. Network-based AV is not present in the Firefly Host, but you can find it in Perimeter. You would use it at Perimeter, right? So that's why the product is called Firefly Perimeter, and you would use the perimeter features like the network-based AV, UTM, like URL filtering on that one. On the other hand, the edge device does not have any visibility of, for example, disk I/O traffic, while that hypervisor product has. So it could do some on the fly or on demand antivirus inspection of the virtual disks. Naturally, the Firefly host is a transparent firewall, so there is no IP address for terminating services. So it's impossible to do some NAT, IPsec, and so on. But this one is present on the Firefly perimeter. So all the things go hand by hand. If you need to do some service like NAT, terminate some OSPF sessions, BGP, whatsoever, you would use the VM. if you need a micro-segmentation, so to separate devices on the same port group, VMware port group, it would be the Firefly host. That's invisible for the perimeter, visible for the host part. All right. In terms of DDoS protection, where to position that one in the data center. We had the previous presentation was elaborating in depth about the Juniper DDoS technology, and the product placement would be following. So depending on the firewall scale, the data center firewall scale, you would position the DDoS appliances in front or after the firewall device. And for the multi-tenancy purposes, so for different customers, different tenants, different applications, you name it, it could be positioned as a virtual machine for particle hypervisors. You may ask how to deal with some volumetric attacks. If the attackers are filling internet pipes, then how to counter these kind of threats. In the recent JDDoS software, Juniper introduced capability of using BGP for signaling to MX routers. So essentially, that DDoS device can signal to upstream router that it's supposed to throttle, rate limit the traffic from some known attackers or IP addresses identified as attackers towards the destination. It's not dropping entirely, it's limiting, and the reason for limiting is that the DDoS appliance still needs to see whether the attack is ongoing or not. Once the attack stopped, that dynamic filter delivered using BGP can be removed. Also, there might be one interesting use case of DDoS appliances in some multi-tenant data center. This technology works also other way around. So it's not necessarily meant just from outside to inside, but it also works from inside to outside. So if there is some customer who is, after some successful attack, member of some botnet, I don't know, spamming heavily or targeting any other customers by DDoS services, these appliances can detect and mitigate attacks from inside to outside. So it could be the first alarm, first device telling you that something is going on and you are being used like some attack source. All right. Previous presentation mentioned security intelligence in, let's say, some conceptual overview. So it was discussing, let's say, what are the components, etc. The next slide is elaborating on, let's say, details and info sources. So for the security intelligence, you can call it also some reputation info feeds. The fundamental feed and the homegrown feed is the Web App Secure technology. What is Web App Secure about? It's a, let's say, reverse proxy being placed in front of web applications, and that one is inserting into the source code of the page traps. If you imagine, for example, modification of cookie values, it could be modification of hidden parameters, some queries, and so on. And it's trying to mislead the attackers. The idea is following. A regular user is not opening up the source code and it's not trying to investigate what this particle field means, what is meant by debug set 0 in a cookie and so on. If someone's tampering these kind of things, then this technology is triggering. And besides taking some actions, reporting, recording the attackers, it's also fingerprinting the attackers beyond IP address. So at some point, it could be possible to insert into the attacker's, let's say, computer, some super cookies, either using some flash storage, regular cookies. There are many ways how you can deal with it, and unless the attacker is using some smart tools or some virtual machines with a rollback options, you can identify returning attackers even if they are coming from a different IP address. And this is something which is being used by the Secret Intel technology. So, if you imagine a Spotlight Secure as a cloud having data from multiple web secure appliances, then data about known command and control channels of botnets, and mention attacker fingerprints, then this one can be or is going to be possible to get it propagated into customer's environment to so-called Spotlight connector, which is yet another virtual machine for the Juno space management. And besides that one, besides the Juniper info feeds, also the local feeds will be possible to propagate into the Spotlight connector at a scale. So it took quite a long time to really develop and announce this technology, and one of the reasons why it's taking so long is that Juniper tends to do the things at scale. So something we are looking at is ability of loading hundreds of thousands reputation records onto firewall devices, onto many firewall devices. So it's not like the particle firewall is speaking directly with the cloud. It's a centralized component, on-premises component, propagating the info feeds into many deployed firewalls in the infrastructures. The NG SPC, so the next generation processing card on the SRX 5K, has 32 gigs of memory for each and every processing unit. So just imagine the options, how many patterns, URLs, cookies, IP addresses can be loaded onto such a massive processing unit. All right. So use cases for the Secret Intel technology. This is the easy one. So the Spotlight connector is receiving IPs, URLs from the Juniper cloud, propagating that to SRX appliances, and if there is some, let's say, successful exploitation of the client-side component like ActiveX, Java, Flash, you name it, then the reverse connection can be blocked, because that can be to the known command and control channel. So first, easy use case. The second one is a bit more complicated. Imagine customer A and customer B, and customer A is subjected to some web application attack. His web app secure is propagating info about the attacker to the Juniper Spotlight cloud, and then this info can make it to the local web app secure appliance. So if the same attacker, although the same attacker is coming from the NAT gateway, may be blocked, because this info is already propagated onto all edge SRX devices. So such an attempt might be just simply dropped. It has some prerequisites, like, for example, the cookie has to be present in the attacker's connection, and that cookie needs to be snooped by the SRX device. So even before getting the chance to tamper web applications, the attacker might be locked, quarantined, dealt with in general. Use case number 3, GEOIP-based inspection. All this is about ability of SRX to have a massive scale of address books. So the first rule could be about denying access from some particular locations, and the second firewall rule could be about permitting and, for example, subjecting the traffic to IPS inspection. Something which could be done is also to have a rule to permit well-behaved countries without IPS, and the rest with IPS inspection. It's gonna be perfectly possible. Use case number 4. There is just rare occurrence of pure Juniper environments. Customers are using many different technologies, different IPS vendors, firewall vendors, some security feeds, own security research, own blacklist, whitelist. All this can be fed into the Spotlight connector and propagated onto the firewall. So whenever you have your own intelligence feed, this is going to be possible to propagate it at a scale into the firewall device. All right. How to manage all the things? Aside of the Spotlight connector, which is coming soon, there's been already for like 2-3 years application, Juno Space application called Security Director. It has evolved a lot. So these days you can use this application for managing many firewalls in one shot, meaning that if you need to propagate one rule to the whole firewall infrastructure, you can do it. It's capable of dealing with a massive scale of rules. I have one customer using 8,000 rules on their firewall cluster, so it's perfectly possible. It has advanced principles of policy inheritance, propagation onto, let's say, firewalls according to group membership, and customers are also appreciating things like 4i principle. So one administrator may be allowed to configure the things, and the second administrator is not allowed to configure, but may be allowed to just see the changes and propagate them onto the firewall. So all these kind of nice things are present within a Security Director. For high-scale logging, we have been using OM technology from IBM Q1 Radar, called by Juniper Secure Analytics. That component can be used for, let's say, log collector purposes, so logging from the Juniper devices, but not only Juniper devices. The main beauty of this one is that if you have any other vendor firewalls, any other networking equipment, it can easily send the logs towards this appliance, and then if you are searching, for example, for some particular source address, it's going to give you results from your Checkpoint firewall, your Cisco firewall, your Juniper firewall, either SRX, Qinos. It's capable of categorizing the data. So single point of view for the logs inside of the network. Besides that, it's capable correlation technology, capable of judging whether the attack was, let's say, applicable, relevant, whether some following events are, let's say, threatening the whole infrastructure. If some IPS event has been seen, then if there is some, let's say, command and control connection, it can take actions, notify you, and also these data can be propagated into the UAC infrastructure using the Open IFMAP protocol. All right. It was very short slot, I did say. So something I could not really cover. Probably the first part, which may be subjected to some next presentation, is how to deal with branch office connectivity. So that would be SRX branch, something able to establish VPNs towards the data center, providing access, providing switching capabilities for some distributed enterprises. This web application technology would probably deserve own presentation, probably taking an hour. So it's interesting technology, worth to look into that one. It could be easily another presentation. I did not really elaborate on the GSA technology. So this correlator CM system collecting flows and logs from different vendors, not just Juniper. And Sergey, in the next presentation, is going to touch the controller and Juno Space, so automation for the service providers and data centers. Thank you very much. I'm more than happy to respond to questions, if there are any. Thank you very much.